Hi everyone, it's Rohan this side. In this video, I'm going to solve the entire mock test paper 1 that is prepared by Lemniscates Academy. Please note that this is just a mock paper, this is not a guest paper. This paper is designed to tickle your neurons to make you think harder as compared to your normal questions. And almost all the questions either are taken from some of the different boards. I have tweaked the questions according to the needs of Cambridge board, and there are some of the questions completely designed by me. So yes, let's get started. So the first question is about binomial expansion, where we are asked to find the term that is independent of x in the following expansion. So what do we mean by a term that is independent of x? This means that we are trying to find a constant term or a term which is having x to the power of 0. So what is the coefficient of x to the power of 0 term? This is a direct question that we are trying to solve it with the help of a general idea of how do you express any term in the following expansion. So I am going to write a general term of NCR times first term, that is x power of minus 2 to the power of r, and the last term 2x to the power of 3 whole to the power of n minus r. I'll just replace n with 5 because I know the value of n in this case. So this is 5cr, and n minus r will mean 5 minus r in this case. Now this term is equivalent to some kind of a coefficient of x to the power of 0. So what I'll do, I'll try to find out the value of r such that the power of x becomes 0. How can I do this? I'll simply compare the powers of x on both the sides. So I'll just say that compare power of x. So it will become minus 2r. Of course, the first term does not have x term. The second term is having the minus 2r. And the third bracket is having the power x to the power of 15 minus 3r. So plus 15 minus 3r, and on the right hand side the power is 0, so I'll just say that it is equal to 0. I'll try to solve for r over here, so it will become 15 is equals to, let me write 15 properly, so 15 is equals to 5r, therefore r is equals to 3. The moment I'm getting r is equal to 3, I can substitute r is equal to 3 over here, and the output of this bracket at the end is going to give me a constant value. We can go ahead and check it. I'll just write therefore term independent of x is 5c3 times x to the power of minus 2 into 3 is minus 6. So I'll just write minus 6. And then 5 minus 3 is 2. 3 power of 2 is going to be 6. So it's going to be 2x cubed to the power of 6. You can see that this x power of minus 6. Okay, wait, my bad. I should have not written it like this. I'll just write it like 5 minus 3. That is 2. Okay. Yeah. So over here, the x power of 6 will get cancelled out this x power of minus 6. That is how we are going to get a term independent of x. So this implies that the term that we are going to get over here is 5c3 and 2 square. So if I just take out my calc and try to solve what is 4 into 5c3, you won't be able to see the calculator. You can do it along with me. 2 square is 4. 4 is multiplied with 5c3. And the value that comes out from my calc is 40. So I know that the term that is independent of x is going to be 40. So this becomes answer to your first question. In case if you're having any doubts, please feel free to ask in the comment section. Now let's move on to the second question. So this question is all about functions. There are two functions given to us, f of x and g of x, where the f of x is a reciprocal function, g of x is a quadratic function. Both of them are given with the respective domains. The first part of the question states that I need to convert this reciprocal function into this format. So let's see how we can do this. I'll write my first part, and I'm trying to compare my this function with this function. So what I can do, I can just say that 3x plus 1 over 3x minus 1 is equivalent to a by bx minus c plus c. So over here, what I can do is I can just take the right hand side and simplify it into a single fraction. So this will become a, and then bx minus c is multiplied with this c. So a plus bcx and then minus c square, right? Minus c into c becomes minus c square divided by bx minus c. So from the denominator, we are able to compare that the value of b is 3 and the value of c is 1. So from here we can say that this implies b is equals to 3 and c is equals to 1. Now what about a? For a, I'll need to compare the constant in the numerator. Why? Because the coefficient of x, which is 3, is going to give me the values of this bc, right? So of course I can compare it, that 3 into 1 is 3. So of course our b and c values are correct. That is just a cross check that I've done. But I can't find the value of a using the coefficient of x. So let me use the coefficient of the constant in the numerator. On the right hand side, what is the constant? It is a minus c square. But the value of c is given to me as 1, or that is what I found over here to be 1. So a minus 1 square should be equal to 1. So this implies that my a minus 1 square should be equal to 1. And from here, I'm going to get a is equals to, if I send this minus 1 on the right hand side, it will become 1 plus 1, which is 2. And then I'll just go ahead and say that because I wanted to express in this format, I can say that therefore f of x is equals to 2 by 3x minus 1 and then plus c, so that is plus 1. This is the format that I was looking forward. So this becomes your answer to the first part of this question. The second part of this question states that we have to find the range of this function where the domain is greater than 1 by 3. So if you have watched my playlist on the domain and range, you know I'm a big fan of drawing the graphs on the spot, right? And then find the range. It will never be wrong. 100% that is a guaranteed thing. If you are able to sketch the graphs properly and if you are able to read the graphs properly, you will never go wrong. So for part B, let me just quickly sketch a graph of this. So the asymptote, the x asymptote will be at 1 by 3 because the denominator will become 0 when x will be equal to 1 by 3, right? Or else if you can just say that this is equal to 0, what is the value of x? So if you make x the subject of formula, x will come out as 1 by 3. So I know that 1 by 3 is the x asymptote and this is my y asymptote over here. So if I try to sketch the graph, let's say this is x equals to 1 by 3. This is my x is equals to 1 by 3. Of course, I'm explaining you, that is why I'm doing it so slowly. If I was doing it in the examination, this wouldn't take me 5 seconds. Okay, under 5 seconds, I can quickly draw this graph. So if you haven't watched the video on how to sketch the graph of the reciprocals, I strongly advise you to go ahead and do that. This is your y is equal to 1. Now the graph can be either in the first and the third quadrant or second and the fourth quadrant. So because the sign over here is positive for the fraction, when the coefficient of the denominator is positive, this means that I'm in the first and the third quadrant. So this is the graph that I'm trying to plot. And because my domain of the function is x greater than 1 by 3, I'm not even going to draw the graph on this side. But let's say if the domain was not restricted, of course, this is the complete graph. But let's stick to the given domain that your x is greater than 1 by 3. So what are the output values over here? I can see that the minimum value that the graph can approach is y is equal to 1. This is 1. And it can go up to infinity. It can go up forever. Therefore, I can say that the range of function f of x is always going to be greater than 1. It goes from 1 to infinity. Why I can't say that it is equal to 1? Because if I say it's equal to 1, I am saying that my graph is going to touch the asymptote. But yeah, my graphs will approach asymptote, but it will never touch. That is why this becomes your final answer for the second part of this question. What is the third part? The third part is to explain whether or not G inverse X exists for the following domain. So let me go ahead and visualize how does the graph look like. If the graph looks like a one-to-one function, of course G of X exists. I mean G inverse of X exists. And if the graph of G of X is a many-to-one function for this domain, the inverse of G will not exist. So let me go ahead and try to do this. So let me give a heading that this is my part C. My G of X is given to me as 4 minus x squared for the domain x greater than 0. I'll always compare, I'll not be rushing. I'll compare if the thing that I've copy pasted is correct or not. So yeah, 4 minus x squared and x greater than 0. Okay. So how can I quickly plot 4 minus x squared? So once again, guys, if you haven't watched the playlist on quadratics function, just like I told you about the inverse function, I'm having a playlist for entire different types of graphs that you can expect in your P1. Okay, so you can watch the entire playlist. So how can I draw this? It's a x square graph, a negative x square graph, which is pulled up by 4 units. So if I just have to plot a rough graph, so my x square graph minus x square graph looks like this, and I'm pulling it up by 4 units. So this is the part of the graph that I'm interested in. Of course, I can complete the graph like this, but because the domain is restricted, so I'm just going to keep it x greater than 0. Clearly from this graph, what are we able to see? Is my g of x a one-to-one function? That is, for each input, I am getting only one output. If that is the case, we call that g of x is a one-to-one function. And when g of x is a one-to-one function, if you try to draw this inverse function, your inverse function will be a valid function. But let's say if g of x was a many-to-one function like this, if there was a turning point, if there is a turning point in your function, 100% that function is your many-to-one function. That is, multiple values of inputs gives you the same output. So when this happens, when a many-to-one function gets converted into a inverse function, it becomes one-to-many. Okay. You remember that in inverse function, we convert x to y and we convert y to x. So many to one means that there are many x values that corresponds to one output. And if you do the inverse of that, that one input value gives many output, this violates the definition of the function. What do you mean by the definition of the function? A definition of function states that for each and every value, there should be only one output. There should be only one output. That is the meaning of a function. But in a one-to-many case, one-to-many is a relation, not a function, okay? Because over here, one input gives you multiple outputs. So because of that, many-to-one functions does not have inverse function. But because over here, we can see that g of x for the given domain is clearly a one-to-one function, g inverse of x will 100% exist. So I'll write a conclusion over here. G inverse x exists because either you can write that g of x is not a many-to-one or g of x is a one-to-one function. Right? So if you take inverse of a 1, 1, you will always get a 1, 1 only. If you do x becomes y, y becomes x, you will still get a 1, 1, unlike what happens in a many one function, right? So this is the conclusion for my third part of this question. I hope you are able to understand this. Now for part D, we have to explain whether or not f gx exists. It means that when I'm going to pass the values of g, that is the range of g, if I'm going to pass it in the function f, is function f capable to take all the values of g of x? If yes, only in that case f gx exists. So what is the range of function g? Let me first identify that. So this is my part D. I know that range of g of x, from the graph I can see that it can take a value of 4 and everything less than 4 is a part of the range. So g of x is less than 4. Okay, why not equal to 4? Because of course, the moment you are getting 4, x value is 0. And because x is not part of the domain of g, the respective value, which is 4, is not part of the range. but just the values less than 4, let's say 3.99999999999, all of that kind of things will be part of the range, and everything below that till negative infinity will be part of the range. So I know that the g of x values are going to giving me the output values that are always less than 4. Now if I compare this with the domain of x, I mean domain of f of x, which was given to me as x greater than 1 by 3. Okay, and right now I'm trying to do what? I'm trying to make a composite function f of g of x. It means that, I just hope that I've written fgx correct. It's not gfx. Yeah, it is fgx for the fourth part. So in this case, I know that the function g is going to take all the values less than 4, and f can accept only the values that are greater than 1 by 3. So the values over here of g is not fully contained by the domain of f. And when a function becomes invalid, when the function f becomes invalid, it becomes invalid for x less than equal to 1 by 3. So if a function f is going to receive any inputs that is less than equal to 1 by 3, the function is going to not show any kind of outputs, and therefore fgx does not exist. Now if you're going to ask me what's going to happen in between 1 by 3 to 4, for this value of g of x, what's going to happen? Of course, the function can give you the output, but the definition of function is that for all the domain, for all the inputs that you are passing, function must give you the output. Only then the function is valid. So in this case, even if there is a single value of g of x that is not contained by the domain of f, still we say that the function does not exist. So over here, of course, there are a lot of values is not contained over here. So we can clearly say that f of g of x does not exist because range of g of x is not within the domain of f. So because f can accept the values that are greater than 1 by 3, but g gives you the values that can go below 1 by 3, that is why this function cannot exist. So this is the conclusion for part D. I'm going in great details to explain this for the students who are very new to this kind of concept. Now let me go ahead and explain part E. What does part E say? Explain whether or not gf of x exists. So now it's the opposite way around. So g f of x means the range of f should be fully contained by the domain of g. So what was range of f that we have identified? The range of f was greater than 1. Now f of x can be anything greater than 1. If I pass that into the g function, can g accept it? G accepts any value greater than 0. So of course, if I pass any values greater than 1, of course, the full range of f of x is being satisfied by this domain of G, and therefore my girlfriend exists. I mean, GF exists. Okay, guys. So I can say that range of f of x is going to be greater than 1, and domain of G is x greater than 0. So because G can accept the values greater than 0, and the function that I'm passing as an input to G, which is f, gives all the values greater than 1, so 100% G fx will exist. So you can write a conclusion that G fx exists as range of f of x is fully satisfied or is fully within the domain of G. So this becomes the conclusion for the fifth part of this question. Of course, you can also find the PDF of the solutions in the description of this video. Over there, you might find a different version of the solution because, of course, I have explained this before in my own academy. So I used that particular thing as the part of the final document, not this one. Now, the last part, F. We have to solve the function f of x is equal to this, giving our answer in the exact format. So what is my f of x? My f of x was 3x plus 1 over 3x minus 1, and that is equals to 2x plus 4. Or you could have also used f of x as this. Okay, it's up to you. So my f of x is equals to 2x plus 4. And what are the values that x can take as an input that are greater than 1 by 3? So I'll just keep in mind, I'll always write, whenever I'm solving a function, I'll always write a condition that my f of x exists for x greater than 1 by 3. So in case I'm getting a value that is going smaller than this or equal to 1 by 3, I need to reject it because the function cannot accept it as an input value, right? So let me go ahead and try to solve this. I know that this is 2 by 3x minus 1 plus 1. I'll compare 2 by 3x minus 1 and plus 1. Now this is equal to 2x plus 4. So of course this is same as writing 2 by 3x minus 1 is equal to 2x. What is 4 minus 1? It is 3. And now I'm going to multiply my 3x minus 1 with 2x plus 3. So it is going to become 2 times 3x minus 1 times 2x plus 3. So 3x into 2x will be 3 2s are 6 x square. Then I'm having what? 3 3s are 9 and minus 2. What is 9 minus 2? Minus 7. I mean, sorry. 9 minus 2 is plus 7. And then 3 minus 1 is minus 3. Okay, I'll just cross check. 3 3s are 9. 9 minus 2 is 7. Okay. Now I just need to go ahead and simplify this further. 6x squared plus 7x minus 5 is equal to 0. Now you can use your CAIE and find the final answers. So if I take out my CAIE and do mod 5 3, of course you can solve it the way that you are used to solve a quadratic expression. So 6, 7 and minus 5 gives me the output values of x as 1 by 2 and minus 5 by 3. So x equals to 1 by 2 or x is equals to minus 5 by 3. From here I'll make a factor that will be 2x minus 1 and then 3x plus 5. This is equal to 0. Now I'll also compare that 2x into 3x is 6x squared. So I know that the coefficient of this bracket is 1. I don't need to write anything over there. But now one interesting thing that you will notice over here is that, as I mentioned, this is the only value that we expect because this is the value that we accept because what? It is greater than 1 by 3. This value is clearly not greater than 1 by 3. So we are going to say that this is rejected. Okay, this is not the final solution because if you put x equals to minus 5 by 3 over here, it will reject it because x has to be greater than this. I just hope this is giving you a proper sense of the functions. If you are able to understand this question, I'm sure that you are having a very powerful concepts for the functions. Now let's move on to the third question. So the first part of this question is about proving this trigonometric identity. So let's go ahead and do this. Part A. I'll start. I can start with either of the side. Let's say I'm starting with LHS. And I highly recommend that whenever you are practicing the trigonometric proving of the identities, you try to go from both the sides, LHS to RHS and RHS to LHS. This is just going to strengthen your concepts of how you can prove the trigonometric identities. Trust me, if you're able to do this for even 10 questions, you will have a significant improvement in your proving of the identities. So over here, I'm starting with the left hand side. And clearly I can see that I want to bring 1 plus cos theta in the denominator. And it's going to be very hard for me to convert tan theta into 1 plus cos theta. So I'm just going to play smart over here. What can I do? I'll just start with 1 minus cos theta over tan theta and then multiply the top and the bottom of this fraction with 1 plus cos theta. Why am I doing this? So that I automatically gets this 1 plus cos theta in the denominator. That is my main purpose, right? And I thought that converting this tan theta into the 1 plus cos theta is going to take a lot of time. That is what I'm thinking. That is why I can surely do this, okay? So let me take this opportunity to help you understand that you can always do this kind of things. Now this is same as writing. On the top it is a plus b, a minus b format. So what is 1 plus cos theta, 1 minus cos theta? It is a square minus b square. So it is 1 square minus cos square theta. 1 square is 1, cos square theta is cos square theta. And on the bottom you are having tan theta, that is multiplied with 1 plus cos theta. Now I can say that 1 minus cos square theta is written as sine square theta, because of course I know there is a formula of sine square theta plus cos square theta equal to 1. So from there I can say that sine square theta is equals to 1 minus cos square theta. Now this is divided by tan theta times 1 plus cos theta. The beauty of trigonometric identities, or I should say the proving of trigonometric identities, is that one can go ahead with multiple approaches and still end up with the same answer. Okay, so it's not compulsory that you follow the same approach, but at the end, if you're getting the correct answer, you should be happy. So now I want on the top only sine theta, not sine square theta. So what I'll do is I'll also don't want tan theta in the bottom. So I'll open the tan theta as sine theta by cos theta and cut one of the sine square theta with the sine theta in the denominator, and the cos theta that I'll be getting, I'll throw it upwards. So let me show you what I mean by this. I'm having sine theta multiplied by sine theta divided by sine theta by cos theta multiplied with 1 plus cos theta. Now this sine theta and this sine theta will go out and this cos theta will go up. And this is same as your right hand side, that is sine theta cos theta divided by 1 plus cos theta. Yes, this is exactly what I wanted, and this is my RHS. So I am done with my proof over here. Moving on to part B. The part B says that we are having a function k sine of 2x plus h, for which the range of the function is 1 to 5. So the minimum value of this function is going to be 1 and the maximum value of the function is going to be 5. We have to find the possible values of k and h. It means that we might have more than one solution for either of the k or h or maybe both. So we need to be careful by the wordings of the question. When they are saying that find the possible values, why would they say possible values? Only if they want to give us a hint that there could be more than one values. Okay. So the domain over here is for all the real numbers. So what can I do? How can I find the values of k and h over here? So this is a very tricky question. Why am I saying it's a tricky question? Let me help you understand this. See, I know that the minimum value of this function will occur when my sine 2x is minimum, which is at -1. I know that the sine 2x graph looks like this, right? This is the graph of sine 2x. The maximum value is 1, the minimum value is -1. So when my sine 2x will be -1, at that time this function k times sine 2x plus h will be minimum. If you're having any kind of understanding of the trigonometric graphs, you will be understanding what I'm saying. If not, again, you can watch my video in the playlist on the trigonometry. It's a 1 hour long playlist. You can go ahead and watch that. So I'm going to say that sine 2x is -1. So minus k plus h is equals to 1. Okay. So I'm going to say that minus k plus h is equals to 1. And when will my function be maximum? It will be maximum when my sine 2x is maximum, which is at 1. So that is k plus h. That is equals to 5. 5 is the maximum value. So I'm going to say that k plus h is equals to 5. Now if I just solve this equation, I'll get 2h is equal to 6. So it means that h will be equal to 3. Right? 2h is equal to 6. So if I solve this, I'll get h is equal to 3. Now what can I do? I can substitute h is equal to 3 back into any of this equation to find the value of k. So this will imply that k is equals to, let's say this is 3, 5 minus 3 is 2. You will say that Rohan, we got only one solutions for h and k, right? That is 3 and 2. There is no possibility for the second answer. So let me help you understand this. If I try to sketch this graph of 2 sine 2x plus 3, it's going to look like this. This is my minimum value of 1. This is my maximum value of 5. And 3 is going to be the middle value. And if I draw the dotted line for the middle value and then try to draw the graph over here, my graph is going to look like this. Yeah, my graph is going to look like this. Of course, the graph can continue in the negative domain also. But now it's important that we understand that k can also become minus 2. Over here, this k can become minus 2. I know that the sin x graph goes like this, but the minus sin x graph starts from the bottom and it goes like this. So if I just say that k is equals to minus 2, in that case, the graph is going to go like this. Something like this. So this purple graph is when my f of x is minus 2 sine 2x plus 3. And the green graph that I've drawn, let me write equal to over here, equal to, it is not looking good. I'll just write equal to like this. So sorry for this, but yeah, I'm not in the mood to erase it right now. This is f of x is equals to 2 positive 2 sine 2x plus 3. And in for both the graphs, if you look for both the graphs, in both of the graphs, the minimum value is 1 and the maximum value is 5. And that is why that was a trick hidden in the question. And therefore, your values of k are plus or minus 2. And for h, it is 3. The middle value is 3 over here. So this will become your final answer. I hope this has given you some idea on how to deal with this kind of a question. And this kind of a question has been asked before in the official Cambridge paper also. A similar question, if not exactly this. If you want to find which question, you can access my Instagram, Lemniscates Academy, that is lemniscates_math. And I'll try to provide this link in the description of this video. If I forget, please mention in the comments. I'll surely add it in the description. If you go into my Instagram, you will find a question on trigonometry over there that is taken from your Cambridge past paper, which explains this concept from the actual examination question, okay, where this kind of concept was being tested. But anyways, I hope this is clear. Now we are going to go for part C. Okay, yeah, the parts is to verify what we have done over here for the domain 0 to pi. All right, so of course we have drawn a rough graph over here. Let me draw a final graph for part C. 0 to pi is the domain. Please note that this 2x means in between 0 to 2 pi, there will be two complete waves. So in between 0 to pi, how many waves will be there? Only one wave. So I'll need to keep that in mind. And if I plot, what are the things that I'll need to keep in mind while I plot? The x values, the x label, y label, then the minimum value of 1, the average value of 3, and then the average value of 5. I mean, the maximum value of 5, right? And then I'll draw both the graph and label it just like this, okay? But I'll also need to write my x values in this case. So it is 0, then maybe pi by 2 somewhere over here, and a pi over here. Please note that I need to draw a complete cycle over here. So how will a complete cycle look like? It will look like this. At pi by 2, it has to be 0, I mean 3. And at pi again, it has to be 3. It will start from here. So this is the graph when k is 2. And this is the graph. This has to be 0 somewhere over here. 1 is the minimum value, please don't forget that. And then it's going to pass over here approximately something like this. And yeah, this is the kind of a graph that you should be getting. Okay. Of course, the graph needs to be smooth, properly smoothly drawn, just like what I've done over here. Okay. This is looking more beautiful as compared to this, isn't it? But yeah, this is the proof of the graph that this is my function f of x is equals to, or I just write that this is my y is equals to, you need to label your graphs always. This is my y is equals to positive 2 sine 2x plus 3. And the blue graph is with the minus sign, right? So y is equals to minus 2 sine 2x plus 3. So we are having a proof and we are able to say that k is having both the values, and for both the values a function can take a minimum value of 1 and a maximum value of 5. Okay. I hope this has given you an idea of how to deal with this kind of a question. Now let's move on to the fourth question. So this question is from sequence and series, where we are given in the first part the first two terms of an arithmetic progression are 1 and sine square x respectively. Show that the sum of the first 6 terms can be expressed in this particular format, where a and b are the constants to be found. So we need to express the sum of the first 6 terms of an AP. So I need to use S6 formula for the AP. So let me do some kind of writing over here that I am given an AP with the first term as 1, the second term as sine square x. From here, I can identify that the value of my value of the d is second term minus the first term, that is sine square x minus 1. And of course, the value of a is equal to 1. Now, I need to know what is my sum of the first 6 terms. What is the formula of sum of the first 10 terms? It is n by 2. So 6 by 2 times 2 times the first term. So 2 times 1 is 2 plus n minus 1. 6 minus 1 is 5. N minus 1 times the common difference. That is sine square x minus 1. I think this question was asked in one of your Cambridge papers only. Now, we have to express the sum of the first 6 terms in the form of cos square x. So I know that there is a relationship of 1 plus sine square, sine square plus cos square is equal to 1. So if I do sine square minus 1, it will be equal to minus cos square. So I know that this QT over here is minus cos square. So I can just go ahead and write this. I can simplify that the sum of the first 6 terms of AP is 6 by 2, which is 3. 3 times 2 is 6. Then 3 times 5. 5 3s are 15, right? 6 by 2 is 3. 3 times 5 is 15. So it will be minus 15 times cos square x. Why minus 15? Because this was minus cos square, right? So minus 5 into 3 will become minus 15, and then the cos square x as it is. And because we are supposed to be finding the constants a and b, I can simplify this and say that a is equal to 6 over here, and b is already having a negative coefficient, so b will be 15. Please don't write b is equals to negative 15. Because of this negative sign is already present, b has to be 15, not negative 15. So this is the first part of this question. The second part of this question is the first two terms of a geometric progression are cos square x and sine square x. And it is given that the value of x lies in this interval 0 to pi by 2. So we are in the first quadrant. We have to find the set of values of x. So of course, multiple values of x for which a progression is convergent. What do you mean by a progression is convergent? A geometric progression is convergent when the terms in GP, let's say whatever are the initial terms, but at the end, the term starts going closer and closer to zero, very, very close to zero. It could be 0.001, 0.00001. So yeah, this is what we call as the progression is convergent. It is converging to a value of zero at the end. And this is only going to happen when the value of r is going to be in between -1 to 1. This is a condition that we learned for sum to infinity. Why the sum to infinity exists only for GP? Because I know that if the value of r is like something like 0 point or minus 0 point something, right? So whenever I multiply my given term with that 0 point something, the next term will always be lesser than the previous term. And if you keep on doing this, eventually you will hit the value of 0 or the value starting to converge near 0. So yeah, this is the condition that r has to be in between -1 to 1 for your series to be convergent, for your GP series to be convergent. So using this ideology, I'll start doing part B over here. For GP to be convergent, r has to be in between -1 to 1. So what is r over here? My first term is cos square x, the second term is sin square x. So it is second term over the first term. That is tan square x in this case, right? Sin square x by cos square x is tan square x. And from here I can say -1 less than tan square x less than 1. Now, if I'm squaring any value, can it ever be -1? It can never be -1. The minimum value that the tan square x can take is 0. So this is same as writing 0 less than tan square x less than 1. Because there are no values in between -1 to 0 that tan square x can give you any output. So I'm reducing the values from, I'm cutting the -1 to 0 values, and this is the new version of the same thing. Now, if I take the square root on each side, I'll be having 0 less than 10x less than 1. So now I need to find the set of values of x. I need to find the set of values of x where my 10x graph is in between 0 and 1. So if I just try to draw this on the graph to explain you what I'm doing over here, how does the 10x graph look like? Let me show it to you. Is there any condition given for the x? Yes. We know that x is in between 0 to pi by 2. So let us draw the diagram between that only. So this is 0 and there is a asymptote, a vertical asymptote at pi by 2, right? This is your pi by 2 asymptote. And how does the 10x graph look like in between this? So there is an asymptote at minus pi by 2 also, and the graph of 10x looks something like this, right? So in between 0 to pi by 2, the graph is looking something like this. So 10x graph is equal to 0 over here, and maybe it's equal to 1 somewhere over here. Okay, it is for this value of x, it will be 1. So because I know that the x-axis is for the angles that 10 is going to take as an input, and the y-axis is nothing but the outputs that the 10x is going to throw, the region of interest is only this much. Okay? This is the region of interest. So when can I get the outputs in between 0 to 1? When my inputs are in between 0 to this value. So when my 10x is equal to 1, what is the value over here? This has to be pi by 4. 10 of pi by 4 is 1. Or you can also do 10 inverse of 1, and your calc is going to throw you the value of pi by 4. So in between 0 to pi by 4, if my x are in between 0 to pi by 4, then my 10x automatically is in between 0 to 1. And for all of these values, I can say that my GP is going to be convergent. So I'll just say that therefore My x is going to be in between 0 to pi by 4. So this becomes your answer for the second part. I hope this question is clear to you, and as usual, if you're having any kind of doubts, please feel free to ask them in the comments. Let's move on to the fifth question. So this question is about circular measures, where the diagram shows a circle with the center O and radius R. And this circle is inscribed in this sector ACE. And this ACE sector is having the circle which is centered at point C. The straight line AC and CD are tangents to the circle at points B and D respectively. The major arc angle of BOD. So BOD, this is a minor arc, this is a major arc. So for this major arc BOD, the angle given to us is 4 pi by 3. We have to show that the arc length AE, the arc length AE means this arc length, is equals to pi r. How can I find this arc length and prove that it is equals to pi r? So for finding the arc length, what is the things that I require? We know that S is equals to r theta. So because I'm trying to find the arc length of the larger circle which is centered at point C, I first need to find what is this radius over here. And then I also need to find what is the angle over here. If I'm able to find these two things, then of course I can find what is the arc length AE. So let's first think about angle. How can I find an angle over here? So if I draw a line over here from O to C, I know it's a right angle over here. I know it's a right angle over here. This is also R. So this triangle and this triangle is similar. So angle over here and angle over here should be identical. So my full circle is of 2 pi. So what is this angle? Let's call it alpha. Okay. Let's call it alpha. How do I find my alpha? I'll start with my first part and say that alpha, that is, I've labeled it on my diagram, that alpha will be from the 2 pi, I am subtracting 4 pi by 3. From the 2 pi, I am subtracting 4 pi by 3. And this is going to give me 2 alpha. From the complete circle, I am avoiding, so from the complete 2 pi, I'm getting rid of 4 pi by 3. I will be getting 2 alpha. So to get one single alpha, I'll need to divide this by 2. So what is this simplified to? So this is same as writing. I'll just use my calci for this very quickly. Or you can simplify it orally if you're good with the oral calculations. So 2 minus 4 by 3 divided by 2 gives me pi by 3. This is coming out to be pi by 3. So this is pi by 3. If this is pi by 3, if this is pi by 2, what is this angle? Because of course I'm trying to find this angle, right? That is my main goal. So let's call this angle beta. This is also beta. So I can say that from here, my beta will be, whenever I draw a triangle, if let's say this is theta, this is 90, this is always pi by 2 minus theta, always, right? Only then if you add these three angles, the summation will add up to 180 or pi radians. So in that way, if this is alpha, which is pi by 3, if this is pi by 2, what is this? Beta has to be pi by 2 minus pi by 3. Which will come out as pi by 6. Now this implies that the angle for the sector ACE, this implies that the angle ACE, the angle ACE is 2 times beta. It's 2 times beta, right? It is 2 times beta, so it is going to become 2 times pi by 6, which equals to pi by 3. So I now know what is the angle required over here. Now I'm just willing to find, how do I find the radius over here? So what I can say is that I am having a diagram like this. I am having a diagram like this, where there is a point O over here, which is making a 90 degrees over here, and then there is a triangle like this. And I know that this is equals to pi by 3. I know this is R, and this is 90 degrees over here. Can I find the length of OC over here? Can I find the length of OC using the SOHCAHTOA? Yes, I can find the length of OC. Now, why am I finding this length? Once I find this length, I already know that this length is R. I know that this length is R. So because this length is R, and if I find the length of OC, the radius of the larger circle will be R plus this value that I'll be finding. That is the reason why am I trying to find the length of OC over here. Okay, I'll just label this as dot 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 R. I mean dash 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 R. So now over here I'll just create a compartment and continue my solution over here. So OC, how will I find my OC? This angle shares hypotenuse and adjacent. So this is my cos of pi by 3. I can say that cos of pi by 3 is equal to adjacent over hypotenuse. From here I can say that my OC is equals to R over cos pi by 3. So now if I use my CAIE, I'll make sure my CAIE is in radians mode. So what is 1 by cos pi by 3? Let me see. 1 by cos pi by 3 is 2. So this is equals to 2 times R, right? R over cos pi by 3 will be 2R. So if this is 2R and if the above length is R, what is the radius? So radius of the larger circle, this implies that the length AC, the radius of the circle, right? The radius of the larger circle comes out to be equal to 2R. 3R. Now I'm having that radius and the theta both. So to find the length, arc length AE, therefore I'll say that arc length AE is equals to R theta. So R in this case is 3R, and the theta, the angle that we got was pi by 3. Let me write it properly. So 3 and 3 gets out, and I'm getting pi r, which is exactly what I wanted. So this is the conclusion for the first part. The main trick over here was to understand that for the arc length of AE, we require what is the radius for that circle and this length. And then we just use the information of this angle and eventually found out the angle over here and the radius of the larger circle, and then we multiplied them and we got this answer. Now moving on to part B. Part B is about finding the exact area. Exact means you're not going to give your answer that is non-exact. So we need to give the exact area of the shaded region in terms of R. Okay, let's look into that. How do I find this shaded region? So what I can do is I'll just use different colors to help you understand. I'll find this area of the major arc BOD. I'll find the area of this major arc BOD. I'll find the area of any of this triangle. I'll find area of any of this triangle. I'll find area of any of this triangle and multiplied by 2 to get also this part of the triangle. And then from the complete area of sector, ACE, from this complete area of the sector, I'll get rid of the area of the major arc BOD and the 2 times the area of a single triangle. Right? So what am I doing? From this entire shaded region, I am getting rid of this much part first, and then I'm getting rid of this entire part on the bottom. So I'll be left with only these two parts. That is the plan over here. So how do you write this kind of things? I'll just write that the shaded area will be equal to the area of the sector ACE, area of the sector ACE minus, I'm going to minus what? The addition of the areas, the 2 times the triangle and the major arc. So area of the arc, area of the arc, what is the area of the arc? BOD, right? BOD major plus 2 times area of triangle. What is the triangle? You can take any triangle. Okay, I'm going to take BCO. You could have also taken CDO. It's up to you. So I'll take BCO over here. And I'll say that my shaded area is equal to, what is my area of the sector ACE? ACE area, the area of the sector ACE is the radius is, I know the radius is 3r. This radius is 3r. And the angle over here was pi by 3. So what is the area of a sector? Half r square theta. So this is half r squared into theta. And what is the area of the major arc, major sector BOD? It will be half into r square into 4 pi by 3. Half into r square into 4 pi by 3 plus 2 times the area of this triangle, okay, whose base is this, or I can just use half AB sine theta. Okay, so in this triangle I know this length, I mean this angle is pi by 6, right? This angle is pi by 6. Let me use another color. This one is pi by 6. Then, oh wait, whenever I am trying to find the area of a triangle, and if I'm having two sides AB, and AB if is shared with theta, how do I find the area of triangle? It is half AB sine theta. So I'm going to use that. If you want, you could have found out the perpendicular height of this triangle and then do half BH, even that is fine. It's up to you. Now, because I know this angle pi by 3, because I know that this angle is pi by 3, so I also know the lengths being shared by the pi by 3 is 2r and r. So I'll use half into r into 2r into sine of pi by 3. So this is half into AB. One side was r, the other side was 2r, half AB, and then sine theta. What was theta? It was pi by 3 if I'm not wrong. Let me check. Yeah, it was pi by 3. Now I just need to simplify this further. And therefore I can say that the shaded area is equals to, if I simplify this, 3 square is 9, 3 square is 9, so 9 over 6, 9 over 6 pi r square minus, this is 2, this is 4, so 2 and 2 gets out, so you are going to get it 2 pi by 3 r square, right? 2 and this is 2, so 2 pi by 3 r square. Then this 2 and this 2 goes, you are left with what? 2r square sine pi by 3. What is sine pi by 3? You can use your calci for that. So sine pi by 3 is root 3 by 2. Okay. So because this is root 3 by 2, This 2 and the root 3 by 2 will get cancelled out. So I'm left with root 3 r square. Okay, half and 2 gets cancelled out. This 2 gets cancelled out with root 3 by 2. So I'm left with the root 3 r square. Yeah, this is correct. You can see how I'm cross-checking my work so that I'm not leaving any kind of room for errors. So finally, this will imply that the shaded area is equals to what? I'll simplify this term because pi r square is constant. What is 9 by 6 minus 2 by 3 in the calci? What is 9 by 6 minus 2 by 3? It comes out as 5 by 6. So it is 5 by 6 pi r square. 5 by 6 pi r square for solving this. And then minus into plus is minus. And then root 3 r square. This will become answer to the second question or second part of this question. Just a quick check. We had to find the area of the shaded region. So we did area of the sector, that was half into 3r square into pi by 3. And then we did minus the area of the major arc BOD or the major sector BOD, that will be half into r square into 4 pi by 3. So that is then half r square 4 pi by 3. And then 2 times the area of the triangle. So area of the triangle, I did it using this length and this length and this shared angle. So half into r into 2r into sine pi by 3. So yeah, everything should be correct over here. So yes guys, this is the process through which if you think that there is a lot of calculations you have done, you can go ahead and cross check your working. So yeah, this is for your fifth question. Now let's move on to the sixth question. So the diagram above consists of 4 different sections A, B, C and D. The function representing the section A is defined as this function, which is valid in between 0 to 1 and 0 to 1 on each axis. So this is also 1, this is 0 and this is also 1. Let Px represent the section B, Qx represent the section C, Rx represent section D, and section A was defined as f of x. We have to determine the functions P, Q, R in terms of f. So this is a question from transformation of the functions. So this has to be minus 1, this has to be minus 1. So let's say if I want to go from f of x to p of x, it's a reflection about y-axis. It means that all the x-axis values are getting shifted. Positive becomes negative, negatives becomes positive. So how can I express my p of x in terms of f of x? It's a function f with the negative x values over here. That shows reflection about y-axis. I have seen a lot of people writing minus f of x. This is not a reflection in the y-axis, this is a reflection in the x-axis because this is y values going from positive to negative, right? So this is the reflection in the x-axis if you write minus outside. So please take a note of this. So the p of x I have represented in terms of f of minus x. This is the first thing that I've done. Now what about q of x? So let's say once I'm having p of x expressed in terms of f of minus x, so it's in terms of f of x, this one is f of x, f of minus x actually. What do I need to do to f of minus x so that it converts to the bottom? So it's a reflection around x-axis. So this is a reflection around x-axis. So now this function will have a minus sign outside. So I can say that my q of x is same as writing negative p of x, right? Because this was my p of x. So negative of p of x is a reflection around the x-axis. and this is same as writing minus of f of minus x. That is my q of x. Now what about d of x? I mean, what about r of x? R of x is simply the reflection of this f of x over here with respect to x-axis. So minus of f of x is this d, and you can write that r of x, that is the section representing d, is minus of f of x. Right? F of x was a section A, and now if you want to reflect this with respect to x-axis, the all the function value becomes negative now. So that is how this graph goes from top to the bottom if you're going to have a minus sign outside. So these are the answers for this question. So a quick question, it tests the knowledge about reflections, and I hope this is clear now. Let's proceed with the next question. All right, so now we are having circles. Part A of this question says that the circle C1 is having this equation. We have to find the center and the radius of this circle. How do you do this? There are multiple ways in which you can do this. You can divide, let's say, the entire equation by 2 so that you get it in the usual format, x square plus y square minus 10x, and then minus 12y plus 112 by 2, whatever is the value, is equal to 0. And after that, you can either go ahead and say that minus of this value by 2 is x coordinate, minus of this by 2 is your y coordinate. Or the method that I like to follow is to convert it into a completing square and then find the center and the radius. You can go with either of the approach, whatever is suitable to you. So I can say that in my part A, my C1 circle is given as x squared plus y squared minus 10x. I'm dividing the entire sides by 2 because I know that I'm only used to solve the equation of circles with the coefficient of x square and y square being equal to 1, not equal to 2. So that was a little bit of trick being played over here. And then minus 12y, what is 112 divided by 2? I'm so sorry, I'm not very good with the oral calculations or the mental calculations. So 112 by 2 is 56, so that is plus 56 is equals to 0 by 2 is 0. Now I can do the completing square over here for C1. So for the x, it will be x minus 5 the whole square. And then for y, if I do, it will be y minus 6 the whole square. Now the extra 25 and 36 will be going on the right hand side along with this 56. So from this, 25 will go to the right hand side. From this, 36 will go to the right hand side. And then this 56 will also come to the right hand side. So I'm having my C1 as x minus 5 squared plus y minus 6 square is equal to, what is 25 plus 36 minus 56? It comes out to be equal to 5. So from here I can say that my center is at 5 comma 6 and the radius is equal to square root of 5. This is always r square, guys, so this has to be square root of 5. Radius is square root of 5. So this becomes answer to your this first part. The second part of this question is saying that there is a tangent to the circle C1 at the point 6 comma 4 that meets the y-axis at point K. So we are having a circle and there is a tangent. So this point also is lying on the circle C1, and that tangent is going to meet y-axis at point K. We have to find the equation of the tangent to the circle C1 at J. Okay, let's see what's given. Let's try to identify this. So we are having a circle. We are having a circle with the center 5 comma 6, and there is a point 6 comma 4. Let's say 6 comma 4 is somewhere over here. Let's call it point J. And now there is a tangent passing like this. And let's say if I draw a y-axis over here, y-axis could be over here, 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 anywhere. So let's say if this is my y-axis, this is my point K, this is my point J. All right. So this is the information given to me over here. The question is to find the equation of the tangent at point J. Simple. All right. So what I can do is I know that the point J is given to me as 6 comma 4. So I can find the gradient of the center to C. Center to J. Let's call the center as point C. So I can find the gradient of MC, and after finding the gradient of MC, I can find the negative reciprocal of that to find the equation of the tangent, or to find the gradient of the tangent. And then once I'm having a gradient of the tangent and this point 6 comma 4, I can find the equation of this tangent very easily. This is the kind of idea in my mind. I don't know why have they given the point K, because I don't think so we're using it anywhere. But anyways, if this is the question, let's deal with this. So I'm going to find the gradient. Let me change the color to green. Gradient of MC is change in y 6 minus 4 over change in x. 6 minus 4 is this, change in x is 5 minus 6. So we are getting 6 minus 4 as 2, 5 minus 6 as minus 1. So this is minus 2. Therefore, the gradient of tangent has to be negative reciprocal of this, which is equals to half. You can see that based on our diagram, we got a negative gradient for this and a positive gradient for this, but it's fine. Okay, it is completely fine. It is just the reason we are getting it over here like this is because 4 will be less than the 4, which is the y coordinate, should be less than this, and 6 is to be right this, right? So that is why the gradient of the tangent would be positive and this gradient would be negative. So just because of our orientation of where I have marked my point J, we have got a problem in the diagram. It's fine, okay, but this is something that I can identify it very easily. It's fine. It's not that the gradient should have been negative, because this diagram is not up to the scale. But if you want to be a bit cautious, if you want to just be a bit cautious, you can just erase this. Just erase this much part and draw it so that you are not having any kind of confusions at looking at the diagram. Okay. So let's say this is 6 comma 4, right? 4 has to be smaller than 6, and this 6 is to the right side of the 5, so this looks good. And now if I draw a tangent, if I draw the tangent like this is point J, and I just found this gradient as minus 2, so the gradient of this tangent is half. I hope now this is clear. Now there is no confusions. Let me clear this out. And of course, let's say if I had to deal something with respect to K also, where is my K? My K is over here now, right? This is my K point, because this tangent is meeting the y-axis at point K. But yeah, this is my kind of a diagram right now. Now, how will I find the equation of the tangent? I'll just write that equation of tangent is y is equals to half x plus c. And I'm going to pass the coordinates which I know of on the line is 6 comma 4 to find the value of c. So c will come out as y minus half x. Y minus half x. 6 by 2 is 3, so c will be coming out as 1. And therefore the equation of the tangent that I've got is half x plus 1. So let me highlight the answer. Now time to move on to part C. Circle C2 is the image of C1. Let me tell you, this is a very repetitive question that I have seen in quite some years in the Cambridge paper itself, that whenever you are having a reflection of the circle, the radius is same. The circle's radius will be same because it's a reflection. Now, how do you find the center of the circle? If you are having the center of the circle and the radius, you can easily find the equation of the circle C2. So to find this, because it's a reflection around this point, I can say that this point Let's call it C dash, a mirror image of the center point. It is J is the midpoint of C and C dash. I can say that. Okay. So there are two ways in which you can find the C dash. You can see that to go from C to J, you need to go 1 unit to the right and then 2 units down. So the same thing you can do over here. You go 1 unit to the right and 2 units to the down. Or you can use the midpoint formula and find the coordinates of C dash. It's up to you, whatever technique you want to use. In both the cases, you will get the same answer. This is x comma y. This is x comma y. So let me use the midpoint formula and show it to you for part C. So to find, I'll use J is equals to midpoint of CC dash. So I know that 6 comma 4 is equal to 5 plus x by 2 comma 6 plus y by 2. From here I can say that my x will be equal to 6 times 2 is 12. 12 minus 5 is my x value, which will come out as 7. And then for y, 4 times 2 is 8. 8 minus 6 is 2. So 7 and 2 is the coordinates for C dash. And therefore equation of the circle C2 is x minus 7 square plus y minus 2 square is equal to the radius is same, which is square root of 5. So r square will become 5. So this is the final answer for the last part of this question. We had to find the equation of C2, and yes, we are done. Let's move on to the next question. Question number 8. Now, this is my favorite question that I've taken from the MadAsMaths, where I have seen a lot of students struggle on this question, and that is why you are seeing this in the part of your mock. So, an open top water storage tank is to be constructed in the shape of a cuboid with a square base of the side x centimeter and the height is h centimeter. Please note that the open top means that there is no surface on the top. The cuboid is having all the sides except the top, and the base is made up of the side x and the height of the tank is h centimeter. The tank must hold a fixed volume of V centimeter cube. So it does not matter that if I'm going to change my X or H, the volume will always be a fixed quantity that is going to become the base area into height, which is X square H. That is something that is very useful for this question. Now, what I can do is I can just draw a rough diagram of what's going on over here. So let's say, let me just draw the base. I hope I'm able to draw it properly. So this is the square base of the sides x. And now I can draw the height. Height could be like this, 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 and this. And now I'm going to create the top of the container. And the top of the container is empty. I mean, it's not there. There is the top of the container is, this is a hollow basically. All the other sides are solid. So for example, if I have to mark it, let me mark it. So this entire thing is going to be shaded, right? Then the sides are also going to be shaded. Sides are going to be shaded. Of course, it's going to be a very weird diagram, but I hope you are getting the idea that this is a cuboid tank where the tank is open. This is the open top. Now, for the first part of the question, I need to find the surface area of the tank. So a lot of students make this mistake that they say that there is an x square. X square is what they say. Actually, when I tried this question for the first time, I did not pay attention myself on this open top, but yeah, that is a trap. So over here we need to know that it is an open square, so you don't need to count the x square on the top. You can just count the x square on the bottom. So that is there. So surface area is equal to x square, that is the surface on the bottom. Now there are how many sides? 1, 2, 3, 4. There are 4 sides. So there is going to be 4 times x times h, because the height of the tank is h. So plus 4 times xh, 4 times the area of the sides. So that is how I'm going to get a total surface area of this cuboid tank, which is having an open top. Now, because I want my answer in terms of V, it means h is not there. But now I know that volume is equals to, base area times height, which is hx square. Now from here I can say that my h is equals to V by x square. I'm making h the subject. So V by x square. And now if I substitute my h over here with V by x square, the surface area will come out as x square and then plus 4x times V by x square. So one of the x gets cancelled out, and this is exactly what we want, 4v over x. So yes, this implies that the surface area of this open tank, cuboid shape water tank, is going to be x square plus 4v over x. So this is the first part. Let's talk about the second part of this question now. Find the value of x in terms of v for which the surface area is minimum. So over here v is not a variable, please note that. Okay, you can't think that a, x and v are variable. Why v is not a variable? Because in the question they have mentioned that we are having fixed volume. Fixed volume means that v is a constant value. So I just need to find the minimum area by doing dA dx is equal to 0. And the question is about to find x, not the value of area, but the value of x at which a is minimum. So if I try to solve part B over here, my area is this. What is my dA dx going to be? I know I can find a stationary value by doing the derivative equal to 0, right? I can find the x value for which the a is a stationary value. So yeah, it is going to be 2x. And then 4v x power of minus 1 is same as writing minus 4v x power of minus 2, which is writing x square. Now this is equal to 0 for the stationary value of a. So I can say that my 2x is equals to 4v by x square. Now the question asked me to find the value of x in terms of v. So I think we are pretty good to go now. So it will be x cube, and 4 by 2 will be 2. So 2 2s are 4. So x cube is equals to v. X cube is equals to 2v actually. And this implies that your x, or let me write, therefore x is equals to cube root of 2v, or 2v to the power of 1/3. Right? I hope this is making some sense of what's going on. So at this value of x, whatever is the fixed volume that you are able to calculate, if you pass that volume, multiply that by 2 and then take a cube root, that will be the value of x at which area is minimum. Now going to part C. If let's say I got two value of x, okay, I need to know which out of the two values are the value of x, or is the value of x where my area is going to be minimum. What am I saying, bro? So sorry for that, like, slight amount of tongue twisters. But yeah, the thing that I'm trying to say over here is that for this value of x, let's say if we have got two different values of x for which a could be a stationary value, it means that a could be a maximum or a could be a minimum. So in that case, if we got two different value of x, in that case we will have to say that which value of x corresponds to the maximum or minimum. But over here, because we got only one value, we don't need to prove it over here. Now for part C, okay, yeah, in part C, we're asked to prove that the surface area is minimum. So yeah, if they are asking you to do it, we are going to do that. So how can we prove that the surface area that we have got is a minimum for the value of x that we have found in part B? How can I do this? Let me use another color. Let me use one of my favorite color that is also the symbol for my academy, that is purple color. So for understanding if the point is minima or maxima for a given value of x, I need to know the double derivative. So I'll find the double derivative d2a over dx2, d2a dx square. So this is going to become derivative of 2x is 2, and then if x power of minus 2 is there, minus 2 will come down, 4 2s are 8, v is a constant value, and then minus 2 will become minus 3, so it will be x power of 3, right? This is my double derivative of this area and x expression. Now I need to know that d2a dx squared at x is equals to the stationary value 2v to the power of 1/3. Is it positive or negative? So I know that if I put x as 2v to the power of 1/3, this 1/3 and 3 will cancel out. So I'll be getting 2 plus 8v by 2v. V cancels out. 2 4s are 8. So this is 1, this is 4. 4 plus 2 is 6. So what do I know over here? I know that therefore, which is greater than 0. So what is the conclusion? A is minimum. Whenever my double derivative is positive, my surface area is minimum, or the stationary value is called as minimum at the respective x value of cube root of 2v. This is the conclusion. Let me highlight it. So this is our final answer for part C. Now for part D, I'll just create an extra compartment over here. So let's go ahead and try to solve for D. Let me use some different color this time. Maybe let me use black color. Okay, black is black. Two together. I don't like it, but it's fine. Let's try to do something over here. Okay, I haven't used blue color. Let me use blue color. Yeah, guys, I'm a bit color conscious. I don't like two colors to be together. It My eyes gets hurt by looking into it. Now for a part D, we have to show that at this minimum surface area, x is equals to 2h. And this is for only 1 mark. So at this value of surface area, okay, so I don't know what is the value of the surface area when x is equals to 2v power of 1/3. But let's say if I put my x as 2v to the power of 1/3, what will happen? I'll get my area in terms of v, right? I'll get my area in terms of v because x is now in terms of v. But then I can't derive a relationship of x and h from that. But what can I do other way over here is the minimum surface area was at x is equals to 2v's 1 to the power of 1/3. And I also know that volume is equals to x square h, right? I know this from here. So what can I do is I can substitute this x square h inside this, or I can make v the subject over here and put that v over here and try to form a relationship between x and h. Now, why can I do this over here? I can do this over here because they've mentioned that at this value of minimum surface area, so I could have either used the relationship of AV if I had to find something in terms of AV, but now because I have to find something in terms of XH, I know that the minimum value of the surface area is coming because of this X. So I'm going to use this X and the fixed value of the volume, that is V is equal to X square H, make V the subject of formula and equate for V and try to form this relationship. That is the idea. Okay. I know D part is one of the parts where a lot of students will be confused that for 1 mark, what are we supposed to do? So yeah, this is what we are doing. Surface area is minimum when x is equals to cube root of 2v. So I can say that from here, v is equals to x cube by 2, that is half x cube. And I also know that my volume is equals to hx squared because I wanted to derive a relationship between h and x, I'm using this relationship of volume because this is a constant value. So half x cube, and this implies that this x square goes out and one of the x is going to remain. So h is equal to half x means x is equals to 2h. And yeah, that is what we had to prove over here. So that is how we are going to do this notorious 8th question of this paper. I hope this has given you some sense of understanding on how to approach this kind of questions. Moving on to question number 9. So we are given a cubic function, and the first part is to simply find its derivative. So first part is pretty easy. F dash x will be equal to 3 2s are 6, x squared minus 24x, and then plus 18. The derivative of a constant is 0, so I'm not writing 0. But this becomes answer for my first part. Straight and easy. Oh yeah, that is why it is 1 mark. Let's move on to the next question, part B. Find the value of x for which f of x is decreasing, and then find the value of x for which f of x is increasing. So B and C, this entire question is pretty easy, right? So what can I do over here? I can just try to solve the f dash x equal to 0 to find the stationary points. So 6x square minus 24x plus 18 is equal to 0. And then I can directly use my CAIE to find the value of x. Mode 5 3 in my CAIE. Of course, you can't see the CAIE again. 6 minus 24 and then 18. It gives me 3 and 1. So either x is equal to 3 or x is equal to 1 is a stationary point. And this means that x minus 3 and x minus 1 becomes the factor of this equation. Now just notice that x into x is x square, but this expression had 6x square. So of course 6 was a common factor, so I just multiply it by 6. So this is my stationary points. So if I just plot a rough graph of the stationary points to understand what's happening, and if you are someone who is following me from a long period of time, you know I am highly dependent on the graphs. So my a quadratic is a U-shaped curve because x square is positive. So this is my f dash x. This point is 1, this point is 3. Is there any restriction on the values for the function? No. All right. So over here, what I can say is for part B, if my function is increasing, or sorry, if my function has to be decreasing, my f dash x has to be below 0. So this is the part of the f dash x which is below 0. So this is where the outputs are negative because this is your x-axis, of course. So in between 1 to 3, your f dash x is less than 0. And for the increasing part, your f dash x has to be greater than 0. So this is the part which is above the x-axis. So this is going to give you a positive outputs. So this region is for greater than 0, f dash x greater than 0. Let me write f dash x also. Over here, this is f dash again. So yeah, for B and C, I can directly write a conclusion now by using this. Therefore, f of x is decreasing for the values of x in between 1 and 3. And the conclusion for part C, let me first highlight this conclusion. And the conclusion for C, let me use my favorite color. F of x is increasing. I hope it was increasing. Yeah, is increasing for when x is either less than 1 or greater than 3. Either on this side, you can say your graph was increasing, or on this side, the graph was increasing. Okay. So this is the answer for my last part. Now let's say if there was a question to sketch the function of uh, the given cubic function. So I know that there are stationary points at 1 and 3, and this cubic graph is increasing like this. So my graph is also having a y-intercept as 15. So my graph is going to look something like this. If at all they had asked this question, the stationary point is at 1. I can find the respective value of y. If I put 1, I'll get some kind of a value. And at 3, I'll again get some value. And my graph was increasing before 1. So something like this. You can say, of course, 15. Let me write 15 as somewhere over here. So my graph is going to look something like this. A stationary point at 1. Then it will come down. It will decrease till 3, right? Now I don't know if it's going to pass the x-axis or not, but let's say if I have to draw something like this, it will go like that. How do I know if it will pass the x-axis or not? By finding the y value. By putting x is equal to 3, I'll get some output, and if the output is positive, it will not pass from the x-axis. If it is negative value, of course, there will be a part where it will cross the x-axis like this, right? So something like this will be the idea. So yeah, if at all you were supposed to draw the graph of this, with the help of the stationary points, the y-intercept, you can easily draw the curve. But yeah, this is not the thing that is asked over here. So let's not focus on this. Just an extra tip, just in case if something like this appears in your examination. But yeah, we are done with the 9th question. Let's move on to the 10th question. So in this question, we are given a diagram that shows a shaded region bounded by the y-axis. This is by y-axis. The line y is equals to -1. And part of this quadratic curve, so of course, if I draw the full quadratic curve, the quadratic curve is going to look something like this, I guess. But now because it is defined for x less than equal to 2, so that is why this part of the diagram is given to me till this point. And in the first part, for x less than equal to 2, we have to express this quadratic in terms of y. So I need to make x the subject of formula basically. When they say express x in terms of y, it means x has to be subject of formula. So whenever a quadratic is given to me and I have to make x the subject of formula, what should we do? We always complete the square. Once we complete the square, there will be only one x term. Everything else is a constant. So yeah, of course, it's easier for us to make the x the subject of formula as compared to what we have over here. So for part A, what I'll do is I'll simply write my y is equals to, I'll complete the square. It will be x minus 4 by 2 is to 2 square. Output will have extra plus 4. So minus 4 plus 3 is -1. Now, if I make x the subject of formula, it will become x minus 2 square is equals to y plus 1. And from here, we can clearly see that therefore, x will be equal to, if I take the square root, it will be plus and minus both. Because of the square, if I take away, it will be a plus and minus both. And then there is a 2 which will go on the right side. -2 will go to the right side and become positive. So 2 plus minus square root of y plus 1. This is my answer for x. But wait, they had mentioned that x had to be less than equal to 2. Okay. So what are the y values, by the way, over here that the graph is taking? My y values, as I can see, is always greater than -1. My y is greater than or equal to -1. So now I'll need to choose which sign, plus or minus, should I use, or should I use both? Let's try to identify. If my y is greater than equal to -1, what happens if I put my -1 over here? -1 plus 1 is 0, so square root of 0. I'll get x is equal to 2. Is x equal to 2 a valid value? Yes. Now let me put a value that is greater than -1. Let me put 0. 0 plus 1. What is the square root of 0 plus 1? It is 1. So now I am having x can either be equal to 2 plus 1 or x can be equal to 2 minus 1 because of the plus minus. Which sign will I choose so that my x is always less than equal to 2? Over here, x is coming out to be 3 with the plus square root, and x is coming out to be equal to 1 with the negative value for the square root. So of course, x is coming out to be less than equal to 2 when the square root is negative, and that is why I'm going to say, that's why I'm going to say that this implies that my x is equals to 2 minus square root of y plus 1, and this becomes my final answer. For any one of you who had taken plus and minus both, clearly your answer was not correct. So here I can see that for my y to be greater than equal to -1 and x less than equal to 2, the negative sign of the square root makes the most sense. Now part B. What does part B say? Hence showing all the working, find the volume obtained when the shaded region is rotated about the y-axis by 360 degrees. So it's about y-axis, which means I need to integrate with respect to dy. So if I'm integrating with respect to dy, I know that the volume with respect to y-axis, if I'm revolving around the y-axis by 360 degrees, if I'm revolving by 360 degrees, it will be pi integration of x square dy. This is the formula. And the integration goes in terms of y limits, which is -1 to 3 in this case, as I can clearly see on the diagram. The limits are -1 to 3. So -1 and 3 over here. So let us continue. Are we having space? Yeah, we are having quite some space. So Vy will be equal to pi times integration from -1 to 3. And now the square of this qt over here, 2 minus y plus 1 to the power of half the whole square and dy. I see a lot of students omitting this dy, but let me tell you, your integration is incomplete without telling with respect to which variable you are integrating. So it's must thing to write your dy to show that, yeah, with respect to my y variable, I am integrating this. So now let me open the brackets over here. So Vy is equals to pi, and then the integration going from -1 and 3. If I open the square, so 2 square is 4, then I need to multiply the 3 terms for the middle term. So 2 times 2 is 4, and then there is a negative this, so -4 times y plus 1 to the power of half. And then I'm having the square of this term, negative y plus 1 to the power of half square. So negative, what's happening? Let me see. I think I need to just get rid of this from a bit. Yeah, this is 2. And I'm going to square this now. So minus square, negative square becomes plus, and the square of this entire term will become y plus 1, because half and square gets cancelled out. And this is with respect to dy. Now let me move on to the next page. Vy is equals to pi, and the integration is going to go from -1 to 3. Let me simplify this equation. I am having a y term. Then I'm having a constant term. 4 plus 1 is 5. So this 4 and this 1 is 5. This y is done. And now only this term is left. -4 times y plus, what was it? Y plus 1 to the power of half. The whole bracket closed, and I need to integrate with respect to dy. As you can see that in every step I'm having dy. So yeah, you need to follow that. Now, if I need to find the volume with respect to y, I'm now going to integrate and then put the limits. What is the integration of y? It is y square over 2. What is integration of a constant? It is constant multiplied by the respective variable y. And over here, it's the same thing, no difference. In the n plus 1 rule, half will become 3 by 2. On the bottom, it is 3, and divide by 2, 2 goes on the top. So I'll just multiply this with 2. And the derivative of this, which is 1, will be multiplied on the bottom. But yeah, this is the kind of an idea that I am having for this integration. And the limits are going to go from -1 to 3. Now, therefore, my Vy is equals to pi. I'm using my calci and substituting 3 in the entire term. So 3 square is 9, 9 by 2. Let me write a small bracket, 9 by 2, right? 3 square is 9 by 2, and then 5 into 3 is 15. Then minus 8 by 3, 4 times 2 is 8, 8 by 3, times 3 plus 1 is 4. 4 to the power of 3 by 2 is what? 4's under root is 2, 2 cube is 8. So this is 8. Now I'll put minus 1 as my limit. So it will be half minus 5, and then minus 1 plus 1 is 0. 0 power anything is 1. 0, sorry, wait. 0 to the power of anything is 0. So of course this entire term has gone to 0. So only this much is left. Now I can calculate what is my Vy finally and then multiply pi with it. I'm going to take calci out and solve it in my calci. You can do it along with me. Of course, you can't see my calci, but you can try to do it. So it's 9 by 2 plus 15 minus 16 by 3 minus half plus 5. This comes out to be 56 by 3 pi. So this is the answer that I've gotten for this part. So this is the volume of revolution around the y-axis by 360 degrees. And with this, we are done with the entire paper. There are no more questions left. But let me just quickly check. I haven't done any kind of an error over here because I'm really good with doing all of this in my calci and the oral calculations. I just suck at that. So if I open my calci once again and put everything in the calci. Oh yeah, so 8 times 8 is not 16, it is 64. So you see, I have done an error over there in my calci. Of course, you can't see it. But then if I try to solve this, I'm getting 8 by 3. Okay. So thank God I checked it over here. It has to be 8 by 3. 8 by 3 pi. And of course, is there any kind of a unit given to us? No, then you can just write unit cube. Okay, this is just my way of writing. So I'll just erase this a bit and write unit cube. And I'm good to go. Units cube. So yes, with this, we are done with the entire paper. One last thing I would like to add before ending this video. If this paper has given you a hard time, please don't worry. This was just to make you think a bit harder. Of course, the final examination will be easier as compared to this. And if you are looking for more mock practice papers for pure math 3, statistics 1, mechanics 1, and if you want to tickle your neurons like this, then yes, make sure that you are joining our WhatsApp group for the same. I'll provide the link for it in the description of this video. And once again, I'd like to thank MadAsMaths and all the other kind of online papers that I've got, which I've used as an inspiration to create this entire paper. So yeah, I hope it was useful for all of you. Thank you so much, guys.